Determine the end behavior of the given function. So here we have a function. It tells us that f of x, remember you can think of that as y, all right, and that will equal negative now x raised to the fourth. And what we want to do here is when they ask us to determine the end behavior of the given function, they're really asking us to determine what happens to the function's value, all right, as x approaches negative infinity, meaning as x goes to the left. And then as, if you had a coordinate system, right, where negative x is to the left and positive x is to the right, that's the convention. And then as x also goes to positive infinity, meaning as it goes to the right on the graph. So what I did was I made a little kind of cheat sheet maybe for us. Take a look. Bam. So you have 4 general cases that you have to be aware of, okay? First thing is determine whether the degree of your polynomial is going to be even, all right, or it's going to be odd, okay? And that's simply by looking at whatever you have here, whatever your function is, it has to be a polynomial, and you're going to be looking then at the highest value of your exponent, okay? The base will be the variable, and here's the exponent. So as we can see, it's even. So what that means is that we're down to now these 2 cases, okay? Then what you have to do is you have to look at the leading coefficient of that variable. And in this particular case, it is negative. Now you have to be careful, because if there were placed a parenthesis here, technically now the leading coefficient is going to be positive, all right? Because there's no number written out there to the left, and it's assumed to be then a positive 1. So with the parentheses there, it would be a positive leading coefficient. Without the parentheses, the leading coefficient there is negative because we can assume that this 4th power is just simply over the x. Okay? Just be careful about that. In any case, that brings us down to this scenario. Now what this tells us is that as x goes out to negative infinity, the y value here, right, it's going to go all the way down to negative infinity, right? So this is negative infinity. It also tells us then that as x goes to positive infinity, the y value will also be going still to negative infinity. And that should kind of make sense, right? I mean, no matter what number you plug in here, at the end of the day, whether it's negative, right? Whenever you have an even power and you have a negative number, pretend it was negative 10, right? With the parentheses raised to the 4th. That's going to be some positive answer, right? It's positive 10,000. There's no way that the number in here will ever become negative. It'll never happen. It's always going to be positive. But your leading then sign is a negative. So essentially there's another negative outside of this, remember? Right? That's what I was kind of mentioning, that you can think about this x as in parentheses. So if the answer in here is always going to be positive, but then you're going to shove a negative on at the end, it can be nothing but negative at the end. Okay? And that's it, right? I mean, that's it. So that's your answer. Now, this graph might not look, this function might not look identical to this, but what I can guarantee you is that these will be definitely true. And go to your calculator, try it, right? Go to y equals, plot it. So just go to x, or type in x raised, negative, do not hit that. That's a subtraction sign. This is the negative sign. So negative x raised to the 4th. No parentheses, just input it exactly how you see it. Okay, and what I'll do is I'll go back, oops. Well, that was a silly mistake. I'll go back over here and just erase those parentheses, okay? Let's go back to the calculator and let's type in a 4. So negative x to the 4th and graph it. And you see, it's frowning at you, okay? That's exactly going to match what I have over here, okay? You can also go to your table, right? Go to second table now, or second graph. Here's your table, right? Notice what's happening, right? As you see, as x is getting more and more negative, the y values are becoming more and more negative, right? This is 1 times 3 to the 1.3 times 10 to the 5th, 1.9 times 10 to the 5th, blah, blah, blah. And as you're now becoming more and more positive, look, it's still going to negative infinity, right? The y value. So you can use your calculator to help you if you want. You should have a good feeling of, if you start plugging in some numbers here for x, what's going to happen. You can memorize this if you want. I mean, there's like 4 different ways I'm showing you how to do it. Whichever way works for you, go for it. Whatever you like. Yeah. That's it. That's all I got for you. Thanks for watching. I'll see you in the next problem.